Okay, we're going to talk about similarity. And in this example, we're going to talk about similarity through dilations and with triangles. So if we look at the definition of similarity, two figures are similar if one of the images, if one is the image of the other under a transformation from the plane into itself that multiplies all distances by the same positive scale factor. That is to say, one figure is a dilation of the other. And we talked about this when we talked about transformations. Dilation just means we're taking one object, one shape, which in this case we've got triangle ABC, and we're dilating it by a factor of 2 for every length. We're just going to multiply by 2, and we will get that new triangle of 20, 12, 14. Since there is a proportion there between the side lengths, so we've got 10 over 20, which is equal to 6 over 12, which is equal to 7 over 14. All of those side lengths are proportional. That tells us that we do have similarity within that triangle. Now if we look at the angles of that triangle, those angles, the similar angles, the corresponding angles, A and D, are congruent. B and E are congruent, and F and C are all congruent too. That shows us that we have that similarity in triangles. The side lengths need to be proportional while the angles are congruent. And if we look here, this theorem we have, this side-side-side theorem, tells us that if three sides of one triangle are proportional to the three corresponding sides of another triangle, those triangles are similar, which is exactly what we saw. We saw a situation where we had proportional sides of the triangle, and since those were in fact proportional, that tells us that those are going to be similar triangles. If we look here, we have DEF, which is a 3, 4, 5 triangle, and we have JGH, which is a 6, 8, 10 triangle. If we set those proportions up, we would have 3 over 6 to 4 over 8 to 5 over 10. Each of those simplified down to be 1/2. Since we have a proportion of 1/2, then we can say yes, those are in fact similar because those three sides are all proportional. The scale factor of DEF to GHJ is going to be 2. So we're going to multiply the smaller factor by 2 to get the larger one. And that's our proportion. We have three sides that are proportional. That tells us those triangles have to be similar. Kind of a different postulate we're looking at is the angle-angle postulate. This tells us that if we have two congruent angles, then those two triangles must be similar. It doesn't tell us anything about the side lengths, which it really doesn't have to, because if we talk through this, it'll make sense that kind of those triangles, they do have to be similar. If we look at example 1, we have angle B and angle Y are marked as congruent. Angle Z and angle C are marked as congruent, which only leaves us to one angle in each of our triangles, which have to be congruent because they are whatever's left over. Whatever rounds out to be 180. If we have now 3 of those are congruent, that tells us that those triangles are similar, which is exactly what we just solved. Example 2, same thing going on here. I've got two 90-degree angles. I've got two 37-degree angles, which means I don't even know what U and E are, but I can tell you that they're the same. And since I have a set of 3 congruent angles in a triangle, that tells me that I have similar triangles. And the last one we want to look at is the side-angle-side theorem. What this tells us is that if we have two corresponding sides of two triangles and they are proportional, and then that angle inside those two angles inside are congruent, then those triangles are going to be similar. If we look here, we have AB, and it tells us over DE. So we have those two sides, and we're saying that that proportion of AB to DE is equal to the proportion of AC to DF. And these two angles are the same, then the entire triangle has to be proportional. Or I'm sorry, similar, not proportional. The entire triangle would be similar. So really all you need to know is a side length, a second side length, and that inside angle. And if you have two triangles where those side lengths are proportional and that inside angle is going to be congruent, which means it's the same, you can say those two triangles are similar because of the angle-angle postulate.